Today I have an NAD AV receiver. This one here has a problem. The sound cuts out on it, according to the owner of it. He bought this unit, I guess, off eBay, and of course, like most stuff that you buy off eBay or any of those other sites like Craigslist, they generally have a problem, and this one here is no exception. And now we know why people throw these things out instead of fixing them, because they're a pain in the ass. Today I'm working on an NAD model T-762. It's an AV sound receiver. I like this. Custom manufactured to NAD specifications in the PRC. So good old NAD, now of Pickering, Ontario, making their products in China. I don't know what's wrong with this beast. I guess we'll turn it on and find out. Sounds like I got a Geiger counter in it. That's kind of a weird sounding symptom. Well, at least we know the amplifier works, because it's increasing the sound of the noise. Let's try, that's on AM. Let's just try. Okay, that was working. I think the right channel's a little low here. I think it's my little test unit. See what else we pick up on this thing.
To hire more staff and judges to process claims. The immigrant minister.
Well, the step is certainly set too low. See if it'll pull it in the other stations. I've just got a small antenna connected up to it now, so the complaint on this was it has no sound. So I don't know what his problem is. It's not making that noise now when I'm on FM. Wonder if there's an antenna on it for AM. Okay, just stuck a piece of wire in the back for an AM antenna.
Hundreds of thousands of dollars in legal bills.
Yeah, lots of noise. We'll see if it picks up my little test transmitter. Yep. Big difference in sound. FM, AM. try some of the other sources on this thing. I just talked to the client. He said he had no sound on the CD input, so I've just plugged in a input onto the CD input, and we're just going to select where is my mode here, CD. Certainly sounds like it's working to me. Oh, wait a minute. It cut out. And now it's just doing this. CD input did cut out. Interesting. Just making that noise. You can see the music's playing. Radio works. I guess we will be taking this thing apart. Cool. Okay, a quick peek down the top of this unit. You can see how well this one's built. And here's our big heat sinks here. Yeah, looks like they got fans. They do. They have fans blowing air through. So there's two fans here that will draw air in and force air through and out the back for cooling. Our analog board is over here, and the first thing I notice on this when I'm looking down at it, just doing a visual inspection, is this capacitor down here looks like the top is bulging up. See what I mean? That cap looks like the top is blown up on it. And that cap is hot. Holy smoke, that cap is hot. Let's put a thermocouple on there and measure the temperature of that thing. So just for fun, let's just see what the temperature of this capacitor is. Let me just get my thermocouple down here, and I'll stick my finger in here and hold it on top. And we'll see if we can measure the temperature of this thing, because it is actually quite warm. If I can get my hand in there onto the top of it. I just touched it and I brought the temperature down, but the thermocouple sitting on top looks like that cap is running around 64, 63 degrees Celsius. There's 64. Yeah, it's just a bit 65, just a bit toasty. Just a bit toasty. So, do you think this might be the problem with this unit? I'll tell you right now, it's certainly not doing it any good. See what I got to get at this. This could be one of these nightmarish units to change that bloody cap. It probably is going to be a nightmarish unit to do it, because, you know, like all modern receivers, nobody thinks to put a hatch on the bottom. So to get at that, to change that capacitor means stripping the entire unit apart. And with a build like this is going to cost this guy big bucks. So to get at that power board to change that filter, I'm going to have to take out the daughter boards here, and then I should, hopefully, if I get these out of the way, I should be able to undo the screws and lift the board out, because the board ends here, right? This is the size of the board is this here. So I got to take all this, I got to strip all this down in order to get into there to change that part. But I'm sure, well, I know that part's bad. I don't know if that's the only fault on it right now, but definitely that part is bad. And with the temperature that thing's getting to, I'm sure it's gone dry and there's a lot of ripple, and that's more than likely what's causing the sound to cut out after it runs for a few minutes. So we got to start this disassembly. That'll be the owner of this thing now texting me. I was explaining to him that the amount of work required, and his reply was, that's the issue with these sort of receivers and why people who buy them give them up. He bought this thing used in a broken condition like this. This fellow brings me a few things to work on. And he buys all this equipment that's usually needing some sort of work because people toss it out. You gotta take the back panel off as well. Get all the screws out that hold the board in place. I just don't know how many there are. There's another one I think down here. There's one or two more that are down here that I have to get out the screws. I should be able to then lift this whole piece out if I get all the screws out. There should be another one down here somewhere, I think. Maybe two more. There's another one right underneath this stupid resistor. Right underneath this power resistor. This, yeah, there's another screw right down there. Dumb place for it. Just like the rest of these bloody receivers, they're all just stupid, dumb designs. I mean, I've seen my share of dumb designs, and this is just right up there with the rest of them. What a stupid design. I've got this out enough now that I can probably change that cap, and I'll resolder the regulators while I'm at it. That regulator looks like its solder is bad. These ones don't look too bad, but I'm going to do them anyway. I'll redo these ones. And yeah, that one looks like it's cracked right there. Well, there's the bad cap. 2200 microfarad, 85 degree, 25 volt. We'll do better than that. As you can see, it was getting very warm. The top is popped. So let's find another one. So I'm going to replace it with a Rubicon 2200 microfarad, 25 volt. This one's a 105 degree Celsius rating. Now, if this is a real Rubicon or not, I don't know. I don't need to hear people telling me it's a fake Rubicon because I don't have any control over what I get when I go. People seem to think, and they always sound off in the comments and bitch about, that's a fake cap you've got there. Again, I don't have any control over what I get. I get what they have at the supplier, and I have to trust that the supplier is doing due diligence and getting real parts. That's all I'm going to say on that. Yes, I understand that there's lots of counterfeit parts out there. You don't need to tell me that. I was probably one of the first people that discovered counterfeit parts about 20 odd years ago when we started buying, I think it was 2SD 1555 and 2SD 1556 horizontal output transistors, only to have them pop after a few hours of use, and we couldn't figure out why these transistors were popping until we actually took a Dremel tool and ground down the epoxy case for it and found that the silicon die was about a quarter of the size of a real one. They had all the same markings. They said Toshiba on them. They looked identical. So I was one of the group here that discovered bad parts and brought them to the attention of the big supplier of the day, who's of course now no longer in business. But he was selling hundreds upon hundreds of these parts, and they were failing left, right, and center. Counterfeit parts do happen. Can't do much about it. I have to rely on the suppliers to do due diligence. So enough said about that. Oops, put that in the way. Just gonna redo these regulators here. I just wanted you guys to see that that is not a short. You might have thought that it looked like a bridge from the other angle, but it is in fact not a bridge. just as difficult to put this back in as it was to remove it. Maybe even more so. I've got the audio input board out. I'm going to remove this crappy circuit glue because this stuff here is bad news. Whenever you see this stuff on the board, it causes all kinds of headaches because it goes electrically conductive as it deteriorates. So we're going to remove this. And since I did have a problem with the analog input for the CD player, this is where the switching is done. It's on this board. So all the input switching is done through these ICs here and fed out through the contacts on the bottom. So I'm going to just take a close look at it and probably reflow the solder on these chips here, and paying particular attention to the CD inputs because the CD input was giving me trouble on this one. And we'll take a look at that. First though, we're going to get rid of the circuit glue because this stuff here is bad news. And if it hasn't failed yet, it will. You guys remember this stuff? Archer. Made in Japan. This should be stronger to scrape through this crap. Of course, Archer was a brand that Radio Shack sold. That was one of their house brands that they sold. It does the job. Jeez, it's on here pretty good, isn't it? It's glued down to this this jumper wire pretty good. I don't need to remove it if it's actually not making contact with multiple conductive traces. If it's just on the wire itself and not making contact with anything else, it's not going to hurt anything. Where it becomes problematic is in areas like this where it's bridging over multiple conductive traces. As when it breaks down, it, as I say, it becomes slightly conductive. It turns it into a resistor. And then you get all kinds of weird things like signal leakage. You know, that's where you're on your tape input, but you can hear the sound coming from your CD player even though it's not selected. Those are the type of problems that this stuff causes. And I'm going to go and just look at the connections on the back side of the board. Make sure nothing's touching. That's good. Okay, that looks okay now. Now we'll just give the switching ICs a good one over here. Okay, these are the switching ICs here. This one connection here looks like it might be compromised. If we look at this one closely, it almost looks like a little crack around that one. So these are the CD inputs. If we follow the traces here, this one goes through here, goes through a jumper over to here, follow it around here, and it comes in through, I think it's into this chip here. Anyway, I'm going to redo both these chips and redo these connections here, just to be sure, because this is a lot of work to take this thing apart to get at this board. I want to try and have all the inputs working on this thing perfectly. And every input works except for the CD input has been giving me some headaches, so we're going to just resolder this chip. These ones aren't too bad to do. There, that looks perfect. What do you think? Perfecto. My iron's not quite hot enough yet. But we'll just do the drag and drag it off here. I'll put some flux on here maybe. Maybe I'll put some flux on. There. That took care of that bridge. Now time to put a few screws back into this thing just so I can test it. And there's a few that I gotta put in here. I gotta line things up here. I gotta bring these heat sinks out of the way too because they're sagging a bit. It's gotta come up a bit to line up the holes. Here we go. That's an insulator that had dropped down. Now to reinstall all the preamp out to main amp input jumpers. I think we can power this thing up and test it. I think I got all the screws in, got all the connectors redone. Let's test this thing. Okay, let's fire this thing up and see if it does anything. Fingers crossed. CD player plugged in. I'm using coaxial input now. Got lots of volume. I'll check one of the other inputs. I've got my MP3 player connected to my DVD input. So I'll just reach around the back here, use myself as an antenna. Actually, I probably don't need to, the signal's strong enough here. I would hope the signal's strong enough. The antenna is right over top of me, the transmitting antenna for this. It's only 100 or a couple hundred milliwatts, but it's enough to get around the house, no problem. I don't have the manual for this thing. I don't feel like looking up how to program it, but the CD input has been assigned digital input 6. So DVD is actually assigned digital input 1, but because there's no digital input, it's going to default to analog. If I plug my optical output from my cable box into the DVD input, it would take the sound from my cable box, and I've already tried that, so I know that it works. But on this thing here right now, the way it's programmed, audio is programmed to digital 6. So as soon as you switch it to CD, it says digital 6 on the screen here, as you'll see, as you can see, and that's one of the coaxial. It's got 2 optical and 4 coaxial inputs, and just the way that this thing has been preset. DVD is preset to digital 1, but because there's no input, it's flashing and it switches to analog, which is what I've got plugged into. Audio, CD, goes to digital 6. It appears to be working. I'm going to let this thing run because the owner of it said that it would cut out. He said all the sound cut out after 10 minutes. I experienced the CD input cut out on it after 10 minutes, but I'll let it run here for a bit. But I'm pretty confident at this point that the problem has been resolved with the replacement of that cap, because as you guys saw, well, here's the cap that came out. You can see the top is bulging on it. Let's just measure the ESR. Besides the fact that this thing was getting red hot, let's measure the ESR. It's going to be through the roof. So we'll zero out the meter first. Okay. And now we'll measure across this bad cap. And this cap measures, what is that, 14? Get this thing up here so we can read it. Measures 1.4. Okay, 2200 microfarad at 25 volts. Well, here we got a 1000 and a 4700, and a 1000 should be no worse than 0.12. 4700 should be 25 volts. Sorry, 1000 should be no worse than 0.08, and 4700 no worse than 0.12. So a 2200 should fall between 0.08 and 0.12, and as you can see, 1.3 ohms. Yeah, this cap is definitely bad, and it was getting hot, as you guys saw. So I think that that was the problem. Pretty confident that that was the problem with this unit. I'm going to let it test run for a while before putting it together, and then of course I'll get some wire ties and tie those down just to make them a little neater before I put the top on. But I think that at this point I've got pretty good confidence that this unit is fixed. Okay, got the unit back together. Working on the audio button there. CD input. That's it, NAD T-762 with the no sound problem traced down to a bad capacitor in the regulator circuit. If you have one of these that's doing weird things, check that cap out. Thanks for watching, and we'll catch you in the next one real soon. Bye for now.